Dear students, so in the last lecture we discussed about the deep learning fundamentals, right? So what is the perceptron, where we can use the perceptron, how the conventional computing is different from perceptron, etc. we discussed, right? So continuity of the lecture, neural network continuation. So in this lecture we will discuss how the neural networks are different from the conventional computing. So first of all, we will discuss in this lecture what is the conventional computing and what is the neural network, how the programming is different from the our learning environment. Like deep learning is how the we call it, why we call it as a learning. So what is the data requirement, handling of uncertainty and noise, parallelism, and some of the concepts related to this one. So these concepts we are going to cover in this lecture. So first one we will discuss what is the conventional computing. So also we can call it as a traditional or classical computing. Right. So first of all, what is the computing? So computing means simply we can say it is a some sequence of instructions. Right. So or we can say some list of instructions. So what we can say, what is the list of instructions? So that is instruction 1, instruction 2, up to so on, instruction n. So also we can call it as this set of instructions is called as a program. Right. So this is about conventional computing. We are already seeing every day. We are writing one program for performing certain task, any task, with the help of some programming lines of code. So that we can say it is a conventional computing. So what it will have? It will have some explicit rules and algorithms. Right. So for example, we want to solve any problem P. Right. So solving that problem P, we have some set of rules and instructions. Right. Algorithm will be designed based on that algorithm. We are going to solve that problem. So also precise and logical operation. So there will be some logical operation to solve that problem. Right. So we may use some different data structure for different operations in the problems. Right. So beauty of this beauty of conventional computing is we already know what is the actual output. So that means that output is predictable. So that means that program we are written. So somehow we are going to predict the output. What might be the output? So this is about beauty of conventional computing. So this architecture is explained about one-man architecture. So it is like computer, memory, control unit, arithmetic, input, output. It is like one computer. So that's why I give an example as a conventional computer example, which is not nowadays. No one is using this one. It is a very old computer architecture. Right. I hope the students are clear what is the conventional computing. So might everyone know conventional computing, how the program is executing, how the program is giving output, how the instructions are executing one by one in a computer. Everyone knows. So this is not a big deal at all to understand. Right. So next one. What is a neural network? So these are what is a neural network? We already discussed in the last class some few fundamentals. Like so, where will the inspiration come from designing of neural network? Neural network inspiration coming from biological and synapses. So it is like biological neuron coming from their human inspiration. Right. So it is connected with some layers like 1, 2, up to so on, input to output layers. Like human being, how the neurons are connected. Similarly, that neurons will be connected layer by layers. Right. So, or we can say nodes also. The nodes we can call it as a neurons. So we can say it is having some learnable weights. So that means that every connection in this one we are having some weight. So that weight we can say it is the importance of that connection. Like for example, this is a take 2, 3, something like that. So it is having connection 0.2, 0.4. That means that this 0.4 having high weightage with respect to the this neuron to this neuron. So it is a weights we can say. So also learn the pattern from data via training or you can say back propagation. So training, we will discuss what is the training and what is the backpropagation in detail in further classes. But training means simply we can say it is learning the mechanism from the data. So we have some data, right? Data is there. From data, the neural network will learn from this data. How it is, data is organized. So from that, it is going to apply the real-time application. Based on the real-time application, we are going to predict or classify whatever you want to based on your requirement. We are going to use that one, right? So this is about back propagation means simply, for example, here there is a output is k 0.9, but you want to output is 0.99. So in that case, what you have to do, 9% less as compared to the your desired one, right? So your desired is 99%, but actual came 90%. So 90% last percent. In that case, what you will do? You will propagate the result into the different layers. So according to that one, the weights will be updated in this connection, so that it will adjust the weights and bias, so that it will give the better output towards the 99. I cannot say it is one time adjustment, it will take 99. It may take, may not be there, it goes works also, but it will update the weights and all those things. So that one we call it as back propagation. So what next one is capable of non-linear function approximation and pattern recognition. So this neural network, what it will do, it will able to have non-linear function. So non-linear function also it is able to capable. So one thing you may get doubt here, whether conventional computing is not able to do. This is also able to do, but problem is that it is, you need to write explicit condition. Whereas here is a neural network, you don't need to write any explicit condition. It automatically it will able to handle the non-linear function directly. So this is one of the beauty in deep learning, right? So next one is the programming and programming versus learning. So what are the major differences? So we discussed definition. First definition, programming is some set of instructions as we discussed just now. So what is the learning? Learning is a process where a system improves the performance from data. So it is not like as a programmer, the programmer will write. So what it will do? It will improve their performance by their own. So that will be some processes defined. From that process, using data, it will be improve their own. So there is no explicit program to give this, do this one, etc. Like, so that is a learning. How it is work means, so follow the fixed logic and code by the programmer. Whereas a learning pattern, it will learn the pattern from model or example. So this is learn the patterns or models from example. So what it will do? That the process automatically it will learn the patterns or model. It will learn the model from the data. So what some data is available, from that data, the model will be automatically, it will learn. So no need to write any explicit program. So this is about working principle. Flexibility. In a flexibility, the programming is like conventional one is a rigid one. It does what you, it means that whatever the program you write, it will do that only. It will not do anything extra. Right? So that's why we call it as a rigid. So whereas learning mechanism is adaptive. So it can change the behavior of that particular model. So it may improve or it may change over the with respect to the time. So this is a more better than the conventional one. So example, calculate graph. This one is a spam filter, learn the email from received email. So this is one of the example. So human involvement, in a human involvement, programmer specify the all logic. Whereas learning, it is no need to specify program providing a model or algorithm, so that automatically that model or algorithm will learn from the given data. Right. So in a error handling, in a programming concept, you have to explicitly you have to solve the code. Whereas learning mechanism, it will reduce the error by using the feedback and optimization. By its own, it will reduce. So where it is used, traditional software, banking system and website. So AML, artificial intelligence, machine learning concept will be used in image recognition, speech recognition, etc. Right. So now next we will see handling of uncertainty and noise. So for example, we discussed just now learning mechanism. The programmer will write a model or process. From that model, from the data, the model will learn automatically. So next question will come, if that data having noise or uncertainty, then how it is handling those situations. So that we can call it as a handling of uncertainty and noise. So our programming like that processor model able to handle the uncertainty or noise. So then that model we can call it as a robust and reliable and generable model for real world data. Right. So neural networks are normally robust to and noise handle to incomplete inputs. So how it is actually handling, it is a beyond scope of our discussion. So but remember how it is handling the noise and certainly it can efficiently handle. So if our time permits, we will be able to discuss with these concepts also, how the neural network will be able to handle the noise and incomplete data in future classes. So conventional algorithm is a brittle outside their specification. That means that in conventional algorithm is not able to handle their outside specification. It means that a program is written for some specific purpose. Right. So this program will do only that specific need only. It will not go behind that one. So that is one of the drawback of conventional one. So probabilistic output allows the neural network to express the confidence. So that means that probabilistic output, there will be some probability output. So that will allow the neural network to express the confidence. So that means the probability is like 9%, 0.99%. So it indicates that this is the confidence levels of the neural network. Right. So next one is the model interpretability. Right. So what is the model interpretability? So for example, you write a program P. Right. So you give some input and it is giving some output. Right. It is giving some output, some in, just say, let us say. So you know what is the input. Right. So already you know what is the program will do, what is the output will come. So that means that whoever the programmer is writing, that programmer able to understand why output is came certain. That means that what I mean to say, for example, you have taken the addition of two numbers, 2, 2 is given. So you written a plus b. So what you get, you know already, 4 will output will come. You know already. Because based on what is the input, what is the output, you can able to predict. And same time, you are able to clearly justify that why this 4 is came. Right. So that is called model interpretability. Right. So model interpretability refers to how well human can understand internal mechanism and decision making process of ML model. So that means that how the model is predicting, how the model is working. So that is called as a interpretability. Whereas the neural networks are black box models. It means that you know input and you are able to see output, but how it is taken decision you don't know. So that's why we call it as a black box model. So that means that basically you are not able to know how the decision is taken by the neural network, why its output is changed like that. Right. So that's why we call it as a black box model. So this one is called as a model interpretability. So conventional programs are typically transparent and debuggable. That means that it is a very transparent, you know what is output, what is output. Debuggable means you can easily able to solve the error, and where this error is coming, you can easily get solved. So neural network often considered as a black box model because we already know this, we don't know how the decision is taken, right? So to provide the model interpretability, there is a one concept called explainable AI, explainable artificial intelligence. So there is an active research is going on in this section to open the black box. That means that how the model decision is taking, how the model is going to be coming to the conclusion. So there will be huge research is going on. So hope soon in a few days or few years you were able to make all deep learning models as a transparent model. I don't know whether it is possible or not, but just I am hoping so. Okay. So next one, performance on perceptual tasks. Right. So what kind of task it is going to be done with a neural networks. So image recognition, speech recognition, NLP, natural language processing. These are the main tasks it can able to do. And conventional algorithm done with the high dimensional sensor data. It means that in a conventional algorithm, if you are having huge data, like volumes of data, the conventional algorithm is able to struggle to handle efficiently. But whereas a deep learning model is efficiently able to handle with respect to the huge volumes of data. So what is the huge value? We will discuss that in later on concept. So neural networks can generalize the pattern that are hard to program manually. It means that so neural networks are generalizable pattern. So some programs you cannot program manually. So in that cases you can able to generalize with the deep learning. So that is one of the beauty of deep learning, right? So next, so this is fine, but when the conventional computing wins, it means that when the actual conventional computing will work, apart from these cases, the deep learning work better, right? So when is the conventional computing wins? So first one is the established system and legacy system. So that means that some of the systems are already existed or established. So those systems it can able to work better, right? So legacy system it can able to work. So conventional well established system it can work better. And one of the advantages it is cost effective. So many user application conventional computing is providing very cost effective solution, right? For it is a often it is a inexpensive in nature, right? High customization and control. It means that you can able to change the their prototype or simulation as per your requirement. You can change and you can control these systems. Most of the time you can able to control 100%. But few cases may not. But most of the time you have higher control as compared to the DL models. Right? Strict compliance and security requirement. So industries with security reasons, the conventional system offer better control, adaptability, making for suitable hardware sensitive data. So that means that if it is some sensitive data is there, you cannot believe directly to the deep learning model, but conventional model is giving very better. So it can have some accountability to auditability to provide those kind of application is better. So everyday task. So some common tasks are like web browsing, gaming, business applications. So conventional computing is better as compared to the deep learning, right? So next one is a certain type of problems. So some problems as compared to the deep learning is a conventional computing is a better. So that is like if problem can be broken into different sequence structures, those kind of stuff. So conventional computing is a better. So next one is the deterministic results. So it means that when if you are able to find the deterministic results, it means that the result should be finite. So in that cases, conventional computing is work better, right? Next one is hybrid approaches. So in hybrid approaches, what to do? Combining the rule-based system with neural networks. So neural networks and rule-based system they are combining. So also we call it as a neuro-symbolic AI. So these are the some of the possible approaches. So we can combine with the conventional computing and neural computing. Right. So next one is using conventional algorithm post-process neural networks output. So these are the one of the hybrid approach. So or you can do pipeline design, leverage the strengths of both paradigms. So what we do? So it will if you do pipeline like conventional followed by the deep learning followed by the conventional, etc. something like that. So that what will happen? So it will that paradigms will give the strengths of both the conventional computing and deep learning models. So next one is limitations of neural networks. So what is the limitations of neural networks? One problem is the data in that. So that means that if you want to run the deep learning model, or else if it is apply the deep learning model, huge data is required, right? So that huge data is required, and automatically it leads to the extensive computational requirements. So these are the one of the limitations in the deep learning. So we may get one doubt. Does it not work with less data? Work, but it will not give the better results. That's the problem. So this is one of the drawback about the neural network. So risk of overfitting, learned bias. So overfitting, we will discuss in upcoming classes what is overfitting. So it means that simply it learns the more data as is required. So over means we can say simply more learning process will become, so that automatically it is not able to fit properly. What is the fitting, what is overfitting, what is underfitting, we will discuss later in the upcoming classes. So lack of transparency. So we already seen why it is a lag with the transparency models, right? So that means that transparency somehow we can improve this transparency with the help of explainable AI model, but it is coming in future days also. Right. Next one is applications of neural networks. So where the neural network will apply. So one is the application is a computer vision, like image classification, object detection, facial recognition, self-driving cars. So this is the most prominent area, research area. So image classification, you might see facial recognition in the attendance system. Many of the offices and governments also trying to implement facial recognition. Government, airports and railway stations, you might see sometime. So these are the one of the application of the neural network, that is a computer vision. So next one is NLP, natural language processing. So machine translation. So like for example, we want to learn English to Hindi or Hindi to English. So machine will be able to translate the language from one language to the other language, like chatbots, text generation, sentiment analysis. There are many applications in NLP. Speech recognition, voice assistant, Siri, Alexa. These are the healthcare applications like digitization, drug discovery. There are many fraud detection, algorithm training, gaming, game development. There are many applications of AI. Just I few I listed here. Okay. So coming to the summary. So neural networks are better and learning Excel, perceptron and leveraging the parallel array. So conventional computing relies on the explicit rules. Choose right tool. So that means that based on your requirement, you may choose for either conventional computing or deep learning. So depends on your application. You need to go for this kind of application, right? This kind of computing. So thank you for watching. If you like my content, please share to your friends or peers or needy people. Thank you for watching. If you like my content, please press the like button. So if you have any queries, you may write on the comments box. Thank you for watching.